This video covers importing data from a CSV into R and then referencing the data. After watching this tutorial, you should be able to import a CSV file into RStudio, alter column names from the data that's been imported to R, and then reference specific values within a data frame. In the video introduction to RStudio, I talked a bit about importing data into R, but I wanted to make a separate video to devote a little bit more time to it. The data set that we're working with today is part of Lab 3. This is a data set of greenhouse gas emissions from different cities throughout the world. So we'll just walk through how to import a CSV. When you're trying to import data into R, it's important to remember that R can only find files that are in your working directory. So the working directory is the file path where R is looking for files. And you can find that by using this getwd command. And so you can see here my set working directory is this file path here, which is not where I have our file that we're using today stored. So I'm going to use this set working directory command, and this file path is where my CSV that we're working with today, this climate lab3 _ climate _ cities.csv, is located. So I'm going to go ahead and hit Control Enter to run this code. And now if I type getwd in my console, you can see my new working directory is now where my file is located, the file path where it's located. If you are working on a Windows computer, to find this information, you can go into File Explorer and find the folder where your file is stored. If you click here, you can copy this file path over to R. Now, one thing that can trip you up is that when you copy the file path from Windows, it will have the / be the opposite direction, so you always have to flip them. So if you have an error, that's usually the first place to look. And again, the R documentation is really helpful, so if you are concerned about any of the arguments for these commands, you can always search them in the search box here. And so the next thing we're going to do is use this read.csv command. And so let's go ahead and search it, where it's a new command that we're using. So it's a data input command, and you can see how it is formatted here. So the first argument, which you don't have to say equals file, you could run it like this, but just to keep things as organized as possible, since we've already set up our working directory, we just have to add our file. If we wanted to look within a subfolder in this larger working directory, we could add that. So let's say I had this file in a subfolder called lab3. I could use this information, add in this additional step in the directory so that R could find my file. And this is a comma separated file, so we are adding this sep, so argument. So this says that each value is separated by a comma. You may have a text file or some other file that you are importing, and when you import it, it may be tab separated or colon separated or some other item. And another thing that's important is this header equals true. So what this command does is it tells R that in this CSV, the first row are the headers of each column. If you have the argument of header as equaling false, then this first row in your data set will be treated as another observation. So if you have a column of numeric values and then header equals false in your code, and you do really have a header, then it can alter the way that this column is classified. It will no longer be seen completely as numeric with this one character value at the top. So it's important to make sure that you are recognizing there are headers. You can omit headers from a data set and you could add them in later, but most of the time, because of data storage practices in our CSV, we tend to already have headers. R is an object-oriented programming language. So one thing to note in this line is that I'm pulling in this CSV and then I'm assigning it this set of symbols right here is equivalent to an equal sign. You can also use an equal sign if you would like. It'll work the same. But with this command, I'm bringing in my CSV and I'm assigning it to this object dat. So I like to use dat to import most data when I'm working, it's easy to type. It's the same thing. I can copy and paste code between different scripts if I'm doing something similar, so I like to keep it simple. But you could also name it something like climate data or climate cities. It's really up to you. So it's important to note that you do need to assign your data to an object to work with it in a script. So if I just run this piece of code without assigning this CSV to dat, I've just imported my CSV, but there's not really anything I can do with it at this point. I can just see it, and now there's no way for me to call this data back other than just running it one more time. If I assign this command, this data to an object, then I can reference it. So now I've assigned it to dat. So at any point I want to call up this data, I can use this object. So when you're importing data, you need to assign it to an object to be able to work with it well. The other command that I like to use when I'm importing data is this head command. It allows me just to look at the first few points of data. This can be especially important to make sure that you don't have errors when you're importing it. It's always helpful to check to make sure that your column names align with what you anticipated, that nothing got shifted. And then another command is this string command that's very helpful. So this string command tells you what's in each column. It'll tell you whether they're integer values, factor values, which are typically characters, and then numeric values. And you can change these. They're also logical values a lot of the time. And you can alter these, and we'll learn about that a bit later in the semester. So at this point, you've imported your data set into R. Before we get started on our analysis and visualization, I want to simplify some of the column names to make our coding a little bit easier. When R imports data for column names, it treats spaces as periods. So the column names can be longer and a bit more complicated. So I'm going to change the column names for some of the columns that we'll use the most during this lab to make them more simple to reference. And so the main response variable for this lab is this scope 1 greenhouse gas emissions. So I'm just going to change this to emissions, and I'm also going to change the population column name. So this call names function will return a list with all the column names for a particular data set. So we have 144 variables, which are represented by 144 columns in this data set. So you can see this fifth position in this list is the emissions that we are looking at. So I'm going to go ahead and reassign that column name to just be emissions, so we don't have to reference that longer name, and you can see it's updated in the data here. And I'm going to do the same thing for our populations, which if we look at this 29th position, you can see it's population others. So it's a lot of periods. It's easy to make mistakes with that. When you're coding, I'm just going to go ahead and update that as well. When we use this read.csv command, it turns the object to which we assign our data to into a data frame. A data frame is essentially just a storage structure that's used in R. It's very powerful for referencing your data and indexing it. So I'll just talk through now how you can reference data within a data frame. So we renamed our column just to be emissions, and so with a data frame, you can use this $sign to call the values in any column. So when I use this $sign, it'll pop up this drop-down list. This is really helpful for avoiding syntax errors, because if I forget what each column name is, it shows them here. For example, if I were to type just emission and leave off the S, I would have an error in my code. So this is a helpful way to avoid errors if you're not necessarily sure what your column name is. And so I'll go ahead and hit enter, and you can see that I've printed all of the values in the emissions column. If I wanted one value in particular, I can go one step further and type my emissions protocol. And so as you remember, it's a column, so each observation is in a different row. So I can use these brackets, and let's say I want this 34th value. So I'll just go ahead and type in 34 here, and now you can see it's printed the value that was in the 34th position in my emissions column. You also don't have to go through column names. You can use column numbers and row names. So in R, you can use these brackets and use two numbers. So your first number is your row number, and then your second is the column number. So if we go up here and we look, let's go ahead and open our data. So we can see that in this second column in first position, we have this value here. So we have our first row and our second column. So let's see if that works. And so you can see it picked this value here. We can test it a little bit further since there are a lot of repeat values. Let's say we want to reference Lima. We can go ahead, and this is now our sixth row, and it's our first column. So now you can see we've returned Lima. And in the same way, you can reference more than just one position in the data frame. So if I wanted to do the first two rows of the entire data frame, I could use 1:2, so that's 1 through 2, and then a comma, and I'll just leave this open. So this space being left open means that I want every single column to be included. So now you can see I've printed the first two observations of every single value, and in the same way we just did that for the top two rows, you could do it for all the rows in a certain set of columns. So that's just a brief overview of how you can reference data within a data frame.